The Panther's fatal flaw, the engineering tragedy of the Panzer V. A predator with a broken heart. July 1943. Kursk. The Panther's combat debut. The crew of the Panzerkampfwagen V had waited months for this moment. They had trained on the new machine in Germany, marveling at its sleek lines, its devastating 7.5 cm KWK-42, and its thick, sloped armor. This was the wonder weapon, the T-34 killer. As they rolled toward the Soviet lines at dawn, the gunner scanned the horizon through his binocular sight, confident that no enemy tank could survive an engagement beyond 1,500 meters. 2 hours later, the Panther sat motionless on the side of a dirt track. The engine ran. The gun was operational. The crew was unharmed. But the tank would not move. The final drive had shredded itself after just 40 kilometers of cross-country movement. As Soviet artillery began ranging in on the immobilized column, the crew abandoned their 50,000 Reichsmark machine and walked back to German lines. To the Allied tankers who would later face the Panther in Normandy, the Panzer V was a mechanical nightmare. It featured the thickest sloped armor of its class, 80 mm at 55 degrees on the upper front plate, and a 75 mm KWK-42 gun that could pierce a T-34's frontal armor from over 2 kilometers away. On paper, it was the perfect predator, faster than the Tiger, better armored than the Sherman, and more lethal than anything the Red Army could field. But the Panther hid a dark secret, one that the German High Command tried desperately to conceal from the frontline units. It wasn't an enemy shell that was the Panther's greatest threat. It was its own heart. Or more accurately, its gears. This is the German Panzer Report. The Design Crisis, Weight versus Engineering. 1941. The Eastern Front. The shock of the T-34. When the Wehrmacht invaded the Soviet Union in June 1941, they encountered a tank that fundamentally changed their understanding of armored warfare. The T-34, with its sloped armor, wide tracks, and diesel engine, was superior to anything in the German inventory. The Panzer III and Panzer IV, which had dominated the battlefields of Europe, suddenly looked obsolete. The German Panzer Commission, dispatched to the front to examine captured T-34s, returned with urgent recommendations. Germany needed a new medium tank, one that combined the T-34's sloped armor philosophy with German engineering superiority. The contract went to MAN and Daimler-Benz. The initial design specifications called for a 35-ton vehicle. At this weight, the engineering was sound. The chosen components. The Maybach HL210 engine producing 650 horsepower, and the AK-7-200 transmission, were designed to handle the mechanical loads of a 35-ton tank with a margin of safety. The final drives, the critical components that transfer power from the transmission to the drive sprockets, were designed as Spur Gears, a simpler, cheaper alternative to the complex Planetary gears used in the Tiger. Then came the intervention. In early 1942, Hitler personally reviewed the Panther designs. His directive was unambiguous: increase the frontal armor. The original specification called for 60 mm. Hitler demanded 80 mm. Then came additional requirements: thicker side armor, a larger gun mantlet, additional fuel capacity. By the time the Panther OSV-D reached mass production in January 1943, the vehicle weighed 45 tons, 10 tons heavier than the original design specification. The engine was upgraded to the HL230, producing 700 horsepower. But the transmission and final drives, the components that bear the brutal stresses of starting, stopping, and turning a 45-ton vehicle, remained fundamentally unchanged. The mechanical stress was about to reach a breaking point. The technical breakdown, the spur gear disaster. Let us examine the fatal flaw in engineering terms. Most heavy German tanks of the era, including the Tiger I, used complex planetary gears for their final drives. These gears distributed the load across multiple contact points, reducing stress on individual teeth. They were expensive, requiring precision machining and scarce alloys. They were difficult to build in large numbers. But they were durable. A Tiger's final drive, properly maintained, could last 1,500 kilometers or more. For the Panther, German industry chose a different path: Spur Gears. Spur gears are simple cylindrical gears with straight-cut teeth. They engage with a single line of contact, concentrating all the driving force onto one or two teeth at any given moment. Under load, this creates immense stress concentrations. The advantage? Spur gears could be cut quickly on standard gear hobbing machines. They required less skilled labor. They were significantly faster to manufacture in the quantities demanded by the expanding Panzer divisions. This was a conscious trade-off, durability sacrificed for production speed. The specific component that failed was the final drive unit, mounted in the front of the hull, connected directly to the drive sprockets. Each final drive contained a series of spur gears reducing the transmission's output speed while multiplying torque. Under the immense pressure of 45 tons accelerating, climbing, or turning in soft soil, these gears would literally shred themselves. The mathematics of failure are instructive. The maximum torque at the final drive input could exceed 4,500 Nm. On a spur gear tooth with a contact patch of perhaps 15 square millimeters, the localized stress could reach 2,000 megapascals, beyond the yield strength of the steels available to German industry in 1943. The gears would deform, then crack, then disintegrate into a shower of metal fragments. On average, a Panther's final drive had a mechanical life expectancy of just 150 kilometers. Some failed in the first 50. A few lucky vehicles reached 200 before the grinding noise began and the drive sprockets locked solid. For a machine designed for mobile, long-range warfare, this was a death sentence before the battle even began. The maintenance nightmare, surgical intervention required. The tragedy of the Panther's final drive was compounded by the complexity of replacement. To replace a single final drive in a Panther, the crew or maintenance personnel faced a nightmare of mechanical disassembly. The entire front hull plate had to be removed. This required unbolting the drive sprockets, disconnecting the steering brakes, removing the front idler wheels, and in many cases, lifting the turret to access mounting bolts. A well-equipped workshop with a crane and trained mechanics could complete the job in 8 to 10 hours, under ideal conditions. In the field, under artillery fire, in the mud of the Eastern Front or the narrow lanes of Normandy, such repairs were nearly impossible. The recovery situation was equally dire. A Panther with a locked final drive could not be towed by standard recovery vehicles. The locked gears meant the tracks would not turn, and dragging a 45-ton tank with locked running gear would destroy the tracks and road wheels. Panthers often had to be recovered by heavy wreckers or, in many cases, simply abandoned and blown up by their own crews to prevent capture. Heinz Guderian, the Inspector General of Armored Troops, visited the Eastern Front in July 1943 and witnessed the disaster firsthand. His memo to Hitler was blunt: the Panther tank currently in service at the front is susceptible to damage in the final drive and steering mechanism. Many losses are due to mechanical failure rather than enemy action. The crews report that after 100 to 150 kilometers, the final drives begin to fail. The battlefield reality, Operation Citadel. July 1943. Operation Citadel. The Panther's massive combat debut. The 51st and 52nd Panzer battalions were equipped with the new Panthers, approximately 200 vehicles in total. They represented the vanguard of German armored technology, and their performance was meant to shatter the Soviet defenses and prove the superiority of German engineering. The results were catastrophic for the Panzerwaffe. By the end of the first day of offensive operations, July 5, 1943, nearly half of the Panthers were out of action. Not from enemy fire, from mechanical failure. Final drives failed. Transmission seized. Steering systems locked. The vehicles that had traveled by rail to the staging areas and then driven just 50 kilometers to their assembly points were already breaking down. On July 10, 5 days into the offensive, the 51st Panzer Battalion reported only 38 operational Panthers out of its original 96. The 52nd Panzer Battalion reported 33 operational out of 90. The troops have lost confidence in the vehicle. By the end of Operation Citadel in mid-July, the Germans had lost approximately 150 Panthers, the vast majority to mechanical breakdown rather than combat. Of those, many were recovered and repaired, but the damage to the Panther's reputation was permanent. The wonder weapon had failed its first test. The failed fixes, band-aids on a broken system. German engineers scrambled to address the crisis. Throughout late 1943 and 1944, a series of modifications were introduced. The OSF. A model, introduced in August 1943, featured strengthened final drive housings and improved gear materials. The OSF G, appearing in March 1944, incorporated further reinforcements and a modified drive sprocket design. Production tolerances were tightened. Heat treatment processes were refined. But the fundamental problem remained: spur gears carrying loads they were never designed to bear. Some units attempted field modifications. Crews were instructed to avoid sudden starts and stops. Cross-country driving was minimized. Panthers were transported by rail whenever possible, even for short distances. None of these measures addressed the core engineering failure. By late 1944, the average life of a Panther final drive had increased to perhaps 300 to 400 kilometers, better, but still unacceptable for a vehicle meant to conduct mobile warfare across the vast distances of the Eastern Front. A Tiger's final drive, by comparison, routinely lasted 1,500 kilometers or more. The contrast was damning. The simpler, cheaper design had proven far more expensive in the long run, consuming tanks that could have been fighting. The statistical reality, exchange ratios and losses. Let us examine the numbers. Total Panther production from 1943 to 1945, approximately 6,000 vehicles. German maintenance records indicate that at any given time, between 30 and 50% of Panthers were non-operational due to mechanical issues. A figure that does not include vehicles undergoing major repairs or awaiting parts. By comparison, the mechanical readiness rate for the Tiger I, with its more robust Planetary final drives, consistently exceeded 70% when not in combat. The Sherman tank, with its relatively simple and overbuilt drivetrain, routinely achieved 80 to 90% readiness. The Panther's combat effectiveness was further compromised by its recovery rate. Because final drive failures often occurred deep in enemy territory or during retreats, many Panthers were abandoned and destroyed by their own crews. The loss of a Panther to mechanical failure was not just the loss of the tank, it was the loss of its crew's training, its weapon system, and its psychological impact on the enemy. A 1944 report from Panzer Lehr Division noted, "The Panther is superior in combat to all enemy tanks." However, its mechanical unreliability means we cannot depend on it for sustained operations. Every offensive must be planned around the expected breakdown rate. The verdict: engineering hubris. Was the Panther the best tank of the war? If you judge solely by the gun and the frontal armor, the answer might be yes. The KWK-42L/70 was arguably the most effective tank gun of the Second World War, capable of penetrating 138 mm of armor at 1,000 meters. The sloped frontal armor, 80 mm thick at 55 degrees, provided protection equivalent to approximately 140 mm of vertical armor, immune to most Allied guns at typical combat ranges. The Maybach HL-230 engine gave it a power-to-weight ratio superior to the Tiger and comparable to the Sherman. But in the reality of total war, a tank that cannot move is nothing more than a very expensive bunker. The Panther's fatal flaw reminds us that in high-stakes warfare, reliability is often more lethal than raw firepower. A tank that reaches the battlefield 90% of the time and kills efficiently when it arrives is worth more than a tank that reaches the battlefield 50% of the time but kills spectacularly when it does. The tragedy of the Panzer V is that it could have been different. If the design weight had been held to 35 tons, if the final drives had been engineered for the actual loads, if planetary gears had been specified from the start, the Panther might have been the war-winning weapon Germany needed. Instead, it became a monument to engineering hubris, a masterpiece of German design, defeated by its own gears. This has been a technical report from the German Panzer Report.